Erwin Rudolf Josef Alexander Schrödinger, /Rodder/ German, {æʁviːn} the 12th of August 1887 to the 4th of January 1961, was an Austrian physicist who developed a number of fundamental results in the field of quantum theory, which formed the basis of wave mechanics. He formulated the wave equation, stationary and time-dependent Schrödinger equation, and revealed the identity of his development of the formalism in matrix mechanics. Schrödinger proposed an original interpretation of the physical meaning of the wave function, and in subsequent years repeatedly criticized the conventional Copenhagen interpretation of quantum mechanics, using for instance the paradox of Schrödinger's cat. In addition, he was the author of many works in various fields of physics, statistical mechanics and thermodynamics, physics of dielectrics, color theory, electrodynamics, general relativity, and cosmology, and he made several attempts to construct a unified field theory. In his book What is Life?, Schrödinger addressed the problems of genetics, looking at the phenomenon of life from the point of view of physics. He paid great attention to the philosophical aspects of science, ancient and oriental philosophical concepts, ethics, and religion. He also wrote on philosophy and theoretical biology. Early years. In 1887 Schrödinger was born in Vienna, Austria, to Rudolf Schrödinger, Saraclot producer, botanist, and Georgine Emilia Brenda, daughter of Alexander Bohr, professor of chemistry, Technische Hochschule Vienna. He was their only child. His mother was half Austrian and half English, his father was Catholic and his mother was Lutheran. Despite being raised in a religious household, he called himself an atheist. However, he had strong interests in Eastern religions, and in pantheism, which were significant influences on his thoughts. He was also able to learn English outside of school, as his maternal grandmother was British. Between 1906 and 1910 Schrödinger studied in Vienna under Franz S. Exner, 1849–1926, and Friedrich Wassenaar, 1874–1915. He also conducted experimental work with Carl Wilhelm Friedrich Fritz Karl Rausch. In 1911, Schrödinger became an assistant to Exner. At an early age, Schrödinger was strongly influenced by Arthur Schopenhauer. As a result of his extensive reading of Schopenhauer's works, he became deeply interested throughout his life in color theory and philosophy. In his lecture Mind and Matter, he said that the world extended in space and time is but our representation. This is a repetition of the first words of Schopenhauer's main work. Middle years. In 1914 Erwin Schrödinger achieved habilitation, Thenia Legendi. Between 1914 and 1918 he participated in war work as a commissioned officer in the Austrian fortress artillery, Gorizia, Duino, Sistiana, Prosecco, Vienna. In 1920 he became the assistant to Maximum Wien, in Jena, and in September 1920 he attained the position of ADO. Professor, or ʻʃroʊdɪŋər Professor, roughly equivalent to Reader, UK, or Associate Professor, US, in Stuttgart. In 1921, he became a professor, or ʻʃroʊdɪŋər Professor, that is full professor, in Breslau, now Wrocław, Poland. In 1921, he moved to the University of Zurich. In 1927, he succeeded Maximum Planck at the Friedrich Wilhelm University in Berlin. In 1933, however, Schrödinger decided to leave Germany. He disliked the Nazis' anti-Semitism. He became a Fellow of Magdalen College at the University of Oxford. Soon after he arrived, he received the Nobel Prize together with Paul Dirac. His position at Oxford did not work out. His unconventional personal life, Schrödinger lived with 2 women, was not met with acceptance. In 1934, Schrödinger lectured at Princeton University. He was offered a permanent position there, but did not accept it. Again, his wish to set up house with his wife and his mistress may have posed a problem. He had the prospect of a position at the University of Edinburgh, but visa delays occurred, and in the end he took up a position at the University of Graz in Austria in 1936. In the midst of these tenure issues in 1935, after extensive correspondence with Albert Einstein, he proposed what is now called the Schrödinger's cat thought experiment. Later years. In 1939, after the Anschluss, Schrödinger had problems, because of his flight from Germany in 1933 and his known opposition to Nazism. He issued a statement recanting this opposition. He later regretted doing so and personally apologized to Einstein. However, this did not fully appease the new dispensation and the university dismissed him from his job for political unreliability. He suffered harassment, and received instructions not to leave the country, but he and his wife fled to Italy. From there, he went to visiting positions in Oxford and Ghent University. In the same year he received a personal invitation from Ireland's Taoiseach, Eamon de Valera, to reside in Ireland, and agreed to help establish an institute for advanced studies in Dublin. He moved to Clontarf, Dublin, became the director of the School for Theoretical Physics in 1940, and remained there for 17 years. He became a naturalized Irish citizen in 1948, but retained his Austrian citizenship. He wrote about 50 further publications on various topics, including his explorations of unified field theory. In 1944, he wrote What is Life, which contains a discussion of negentropy and the concept of the complex molecule with the genetic code for living organisms. According to James D. Watson's memoir, DNA, The Secret of Life, Schrödinger's book gave Watson the inspiration to research the gene, which led to the discovery of the DNA double helix structure in 1953. Similarly, Francis Crick, in his autobiographical book What Mad Pursuit, described how he was influenced by Schrödinger's speculations about how genetic information might be stored in molecules. However, the geneticist and 1946 Nobel Prize winner H. J. Mueller had in his 1922 article Variation Due to Change in the Individual Gene already laid out all the basic properties of the heredity molecule that Schrödinger derives from first principles in What is Life, properties which Mueller refined in his 1929 article The Gene as the Basis of Life, and further clarified during the 1930s, long before the publication of What is Life. Schrödinger stayed in Dublin until retiring in 1955. During this time he remained committed to his particular passion. Involvements with students occurred, dubious, discuss, and he fathered 2 children by 2 different Irish women. He had a lifelong interest in the Vedanta philosophy of Hinduism, which influenced his speculations at the close of What is Life, about the possibility that individual consciousness is only a manifestation of a unitary consciousness pervading the universe. A manuscript fragment from an unpublished dialogue of Galileo from this time recently resurfaced at the King's Hospital boarding school, Dublin, after it was written for the school's 1955 edition of their Blue Coat, to celebrate his leaving of Dublin, to take up his appointment as chair of physics at the University of Vienna. In 1956, he returned to Vienna, chair ad personam. At an important lecture during the World Energy Conference he refused to speak on nuclear energy, because of his skepticism about it, and gave a philosophical lecture instead. During this period Schrödinger turned from mainstream quantum mechanics' definition of wave-particle duality, and promoted the wave idea alone, causing much controversy. Personal life. Schrödinger suffered from tuberculosis and several times in the 1920s stayed at a sanatorium in Arosa. It was there that he discovered his wave equation. An Emery and Erwin Schrödinger's gravesite, above the nameplate Schrödinger's quantum mechanical wave function is inscribed. On 4 January 1961, Schrödinger died in Vienna at the age of 73 of tuberculosis. He left a widow, Annie, born an Emery Bertel on 3 December 1896, died 3 October 1965, and was buried in Altbach, Austria. Scientific activities. Early activities. Early in his life, Schrödinger experimented in the fields of electrical engineering, atmospheric electricity, and atmospheric radioactivity. He usually worked with his former teacher Franz Exner. He also studied vibrational theory, the theory of Brownian movement, and mathematical statistics. In 1912, at the request of the editors of the Handbook of Electricity and Magnetism, Schrödinger wrote an article titled De-Elektrism. That same year, Schrödinger gave a theoretical estimate of the probable height distribution of radioactive substances, which is required to explain the observed radioactivity of the atmosphere, and in August 1913 executed several experiments in Seeheim that confirmed his theoretical estimate and those of Victor Franz Hess. For this work, Schrödinger was awarded the 1920 Haitinger Prize, Haitinger Preis, of the Austrian Academy of Sciences. Other experimental studies conducted by the young researcher in 1914 were checking formulas for capillary pressure in gas bubbles and the study of the properties of soft beta radiation appearing in the fall of gamma rays on the surface of metal. The last work he performed together with his friend Fritz Karl Rausch. In 1919, Schrödinger performed his last physical experiment on coherent light and subsequently focused on theoretical studies. Quantum mechanics. Old quantum theory. In the first years of his career, Schrödinger became acquainted with the ideas of quantum theory, developed in the works of Maximum Planck, Albert Einstein, Niels Bohr, Arnold Sommerfeld, and others. This knowledge helped him work on some problems in statistical physics, but the Austrian scientist at the time was not yet ready to part with the traditional methods of classical physics. The first publications of Schrödinger about atomic theory and the theory of spectra began to emerge only from the beginning of the 1920s, after his personal acquaintance with Sommerfeld and Wolfgang Pauli and his move to Germany. In January 1921, Schrödinger finished his first article on this subject, about the framework of the Bohr-Sommerfeld effect of the interaction of electrons on some features of the spectra of the alkali metals. Of particular interest to him was the introduction of relativistic considerations in quantum theory. In autumn 1922 he analyzed the electron orbits in an atom from a geometric point of view, using methods developed by the mathematician Hermann Weyl, 1885 to 1955. This work, in which it was shown that quantum orbits are associated with certain geometric properties, was an important step in predicting some of the features of wave mechanics. Earlier in the same year he created the Schrödinger equation of the relativistic Doppler effect for spectral lines, based on the hypothesis of light quanta and considerations of energy and momentum. He liked the idea of his teacher Exner on the statistical nature of the conservation laws, so he enthusiastically embraced the articles of Bohr, Kramers, and Slater, which suggested the possibility of violation of these laws in individual atomic processes, for example, in the process of emission of radiation. Despite the fact that the experiments of Hans Geiger and Wilder both soon cast doubt on this, the idea of energy as a statistical concept was a lifelong attraction for Schrödinger, and he discussed it in some reports and publications. Creation of wave mechanics. In January 1926, Schrödinger published in Annalen der Physik the paper Quantisierung als Eigenwert-Problem TR. Quantization as an Eigenvalue problem, on wave mechanics, and presented what is now known as the Schrödinger equation. In this paper, he gave a derivation of the wave equation for time-independent systems, and showed that it gave the correct energy eigenvalues for a hydrogen-like atom. This paper has been universally celebrated as one of the most important achievements of the 20th century, and created a revolution in quantum mechanics, and indeed of all physics and chemistry. A second paper was submitted just 4 weeks later that solved the quantum harmonic oscillator, rigid rotor, and diatomic molecule problems, and gave a new derivation of the Schrödinger equation. A third paper in May showed the equivalence of his approach to that of Heisenberg, and gave the treatment of the Stark effect. A fourth paper in this most remarkable series showed how to treat problems in which the system changes with time, as in scattering problems. These papers were the central achievement of his career, and were at once recognized as having great significance by the physics community. Color. One of Schrödinger's lesser-known areas of scientific contribution was his work on color, color perception, and colorimetry, Farbenmetrik. In 1920, he published 3 papers in this area. Theorie der Pigment von größter Leuchtkraft, Annalen der Physik, 4, 62, 1920, 603-22, Theory of Pigments with Highest Luminosity. Grundlinien Theorie der Farbenmetrik im Gesetzen, Annalen der Physik, 4, 63, 1920, 397-456. 481-520, Outline of a Theory of Color Measurement for Daylight Vision. Farbenmetrik, Zeitschrift für Physik, 1, 1920, 459-66, Color Measurement. The second of these is available in English as Outline of a Theory of Color Measurement for Daylight Vision in Sources of Color Science, edition. David L. McAdam, The Mid Press, 1970, 134-82. Legacy. The philosophical issues raised by Schrödinger's cat are still debated today, and remains his most enduring legacy in popular science, while Schrödinger's equation is his most enduring legacy at a more technical level. To this day, Schrödinger is known as the father of quantum physics. The large crater Schrödinger, on the far side of the Moon, is named after him. The Erwin Schrödinger International Institute for Mathematical Physics was established in Vienna in 1993. A building is named after him at the University of Limerick, in Limerick, Ireland. The University of Limerick, in Limerick, Ireland. The University of